Halo, Assalamualaikum and selamat sejahtera. My name is Muhammad Faiz Abdul Rahman and I was supervised by Dr. Sohaila binti Sari and to our panels, Dr. Khalid bin Isa and Dr. Chu Chen Chun. So my title for final year project 2, enhancement of lake underwater image for visibility improvement. So this is a problem statement for our title, which is an image taken under low light condition, usually undetected with low light and de-hazing. And DSLR with high ISO still not able to solve this problem and challenging for checking underwater image or underwater environment. For lake underwater image, which is suffer from poor visibility due to attenuation of the propagated light and haphazard attenuation of the light underwater causes of foggy and misty appearance. So this is our objective for this project. The first objective is a proposed enhancement technique to improve the quality of lake underwater image, and second, develop a computer-aided system to clear the water particle in the lake underwater image. And the third objective is evaluate the performance of proposed technique. So this is my scopes for the project. First one is MATLAB software. Second, test image from lake in front of G3 intention. And third one is focus on lake underwater image. Okay, so now we go through on the literature review, the previous dazing method. Okay, now we go to literature review. This like from year 2015 is method color attenuation by year. Advantage for this method is faster achieve efficient processing when hazy image large, but limitation for this method is miscalibration will result in accurate estimation of the depth in some cases. In 2008, contrast maximization advantage is enhance the visibility of the image, and this method does not specifically improve the brightness of depth of the image. And the third one is 2008 independent component analysis, which is an advantage, increase scene visibility and recover haze-free scene contrast, but limitation for this method is unreliable because it does not work well for dense haze image. And 2011 reduction of fire, which is advantage single image is used for restoration of foggy image and transmission map is estimated accurately. And this method is invalid when since object is similar to a light. And then 2018, fast dazing reduction of fire, which is a advantage image contrast reduction, thick haze removal, but limitation is increase the thickness of the haze when the haze in the image is not removed clearly. So now we go to previous contrast analysis method. At 2007 is contrast stretching. Advantage for this method is improve an image by stretching the range of intensity value it contains to make a full use of possible value, but limitation of this method is contrast stretching is restricted to the linear mapping of input to output values. The result is less dramatic but tends to avoid the sometimes artificial appearance of equalized image. And 2013 is multi-scale Retina-X. The proposed method is used to overcome the limitation of single-scale Retina-X. The method focuses on the luminance of the image, and limitation is execution time is less. And histogram equalization is simple and enhance contrast of an image. And limitation if the values that are physically far apart from each other in the image. And the method 2016 discrete Gaussian transform. Each DCT possesses several traits that make it an effective tool for image compression, and the transformation is orthogonal. And limitation is input from preprocess 8 times 8 blocks are integer value. The output values are typical real value. And the last one is contrast limited adaptive histogram equalization technique, which is his Klahi. The Klahi uses a contrast amplification emitting procedure that is applied for its neighboring pixel, which then form a transformation function in order to reduce the noise problem. And this limitation for this method is cannot be practically for large range of low contrast image. Okay, so now we go to the methodology. Okay, now we go to the project development. The first one, we start and study and literature review and do a system development and find result and analysis and do a report writing. Okay, now we go to the first methodology is we use histogram equalization, which is HE. As we can see, the starting image, we will input image in RGB format, and then if we convert RGB image into the HSV, and we will divide 3, which is HVS, and apply to histogram equalization and assemble all the channels to form the HSV image and convert into RGB format back, and then we'll come up with output RGB image. As you can see, the image from this right, image that already enhanced by histogram equalization. So the second one for methodology is image enhancement technique, contrast limited adaptive histogram equalization. As you can see, this is output for Klahi after the enhance, and then as you can see, input from this the image, which is original image, and convert from RGB to ISS, and subjecting the image into Klahi and produce the histogram for each contextual region and clip the histogram according to the clip limit, and ISS converted back to the RGB, and we come up with output contrast enhanced image. And the result is will be like this. From original image, using Klahi, we will output this one. This is using method image de-aging technique, which is using method that China prior. This is original image in forest. As you can see, the output of DCP is different from the original image. This one is starting from the input as image and do some dark channel estimation and add small space, light and transmission, and then go to scenes gradient and go to contrast adjustment and do sky masking, and then they will come out the recovery image. And then this one is first de-aging that scenario prior, and this one is visual inspection for that scenario prior, first de-aging that scenario prior, which is like this is your original image and then the output of first de-aging that scenario prior. So this one is we input his image and estimate at atmospheric light, and then transmission map estimation and transmission map refinement and image reconstruction, and we come up with output of the haze image. So for the methodology, we propose the hybrid from contrast enhancement to de-hazing, which is like we combine two methods to enhance the image which is what's more suitable for underwater lake image. The first proposed method is histogram equalization combines Dutch and Prior. Firstly, we should um, input the image and then perform a contrast enhancement, which is a do HE contrast enhancement, and come up with output image. And then after that, we perform the hazing Dutch and Prior, and then we come out the his output image. And the second proposed method is histogram equalization combines that first dehazing Dutch and Prior. This is same. Okay, now we go to the proposed method 2, which is combination between histogram equalization and combines to first dehazing Dutch and Prior. And this one is still same with the previous method, which is do input image and perform contrast enhancement first, and we come out with the output image, and we perform dehazing, which is a fast dehazing Dutch and Prior, and this is the we come up with this is output image. So this is our proposed method 3, which is combination contrast limited adaptive histogram equalization, which is Klahi combines with Dutch and Prior. And it's still same. We're using the flow chart, which is we perform contrast enhancement first, which is Klahi, and we come up with output image and perform dehazing Dutch and Prior, and we come out with the image enhancement from this method. And proposed method 4 is contrast limited adaptive histogram equalization Klahi combine fast dehazing Dutch and Prior. Then this is for chart for this method, which is first we input the image and perform contrast enhancement Klahi, and from we got the output image, we perform the dehazing, which is fast dehazing Dutch and Prior, and we come up with this output image. So this is input underwater image in late session at Z3, and this one is graphical user interface UI, which is that I created, and we will do some common analysis for contrast, which is a perfect perceptual substance index, which is PSI, root mean square, RMS contrast, luminance. Okay, now we go result and analysis part. So I have a 3 test image, which is for the first one, test image for near object, and second one is test image for object, and the third one is test image without the object. And then this test image we do at the proposed method, and then do some perform evaluation. Okay. Okay, the first one, image enhancement technique, which is comparison histogram equalization HE, and contrast limited adaptive histogram equalization is Kahi. And then as you can see, this is visual inspection for this comparison for image enhancement techniques. So as you can see, Klahi have a good and have a sharpness very clearly better than HE, and have a detail and have a better quality, better than histogram equalization. And then we go to the perform evaluation, which is as you can see from the RMA contrast, is Klahi is the most highest than histogram equalization for the RMA contrast. And then for luminance contrast, Klahi is still the highest for the 3 categories between histogram equalization. And then for average computation time, histogram equalization compute the shortest time, compute the image within in the shortest time, then the Kelahi takes 5 seconds, and histogram equalization takes only 7 on 0.76. And then for the PSI, for this comparison, Kelahi shows the most highest than histogram equalization. And then now we go to image dehazing technique, which is comparison within dark channel prior and fast dehazing dark channel prior. This is visual inspection, as you can see, between dark channel prior and fast dehazing dark channel prior for the three test image for the different categories. Okay, this is a performance evaluation for comparison, which is that channel prior compute the more highest aromatic contrast than the fast dehazing. And then for luminance, that channel priors doesn't have a value within fast dehazing that channel prior. And then for average compositional time, fast dehazing, it takes the shortest time to compute the image and to process this image. And for average, the sharpness PSI, fast dehazing that channel prior got a value than that channel prior. And then this is first proposed method, which is combination between histogram equalization combined to that channel prior. The first proposed method to become an effective enhancement for underwater image lake. So as you can see from this visual inspection, this is the result after this combination. The first one is for the near object, and then the second one is for object, and then the third one is for without image. And then this is what I do for a performance evaluation, which is average for the the 5 test image, which is, and you can see at the report. Okay, and average aromatic contrast, shows the good contrast for this method, good contrast and have a good luminance, but uh, uh, have a good uh, have a good actually that's not good my contrast, which is only good for average luminance, but only and good for PSI, but at the compositional time take the longest time for to compute image. So this method is good for luminance, and but and about average PSI. Okay, now we propose this method too, which is a combination histogram equalization combines that channel prior. Okay, now we go to our discussion is the first one, which is objective. Objective one is propose enhancement technique to improve the quality of lake underwater image. And of course, we got an effective combination between contrast limited histogram, which is Kahi, and fast dehazing that channel prior is proposed to give the best solution to increase visibility lake underwater image. And then the second objective, develop a computer-aided system to clear the water particle in the lake underwater image. Graphical user interface is developed using MATLAB software. It could help the user in applying the proposed method and resulting method on the desired image, either to analyze or enhance the image. And then we do the third one is evaluate the performance of proposed technique. The performance evaluation of proposed method, which is a combination between Kahir and fast dehazing that channel prior, shows the the lowest value primary contrast, but the highest value of luminance, and perceptual sharpness index got the highest value, and also take a shorter time to compute the image. In terms of visual effect, uh, proposed method produce filter image with a better quality. And then we go to the recommendation, which is there are some suggestions here for future project developer to improving the existing system. It is make a survey and get the number of respondents participating in the survey to increase the accuracy of the result in terms of visual effect inspection, and then obtain the image dataset with length to investigate the effective of the proposed method. And then the third one is updating graphical user interface to make it more user friendly. And then this is our conclusion, which is in conclusion, enhancement underwater image lake for visibility improvement has succeeded using an effective image enhancement hybridization between Clahi and fast dehazing Dutch Empire has succeeded in achieving the objective. Thank you. But now, as you can see, you can go to demo. Okay, this one is a demo project. This one is demo project. As you can see, this method, this part is for dehazing method, and this one is for part contrast enhancement. And then this one is hybrid techniques, which is we only use for this method, which is contrast enhancement to dehazing. And this one, the fourth one, this one is from dehazing to contrast enhancement. Okay, and now we go to the input. It's like, okay, now we test for in the forest image, as you can see. So using this, we are doing that signifier, and then we got the result from here. And then this one is button pop-up for the image. Okay, as you can see, this is pop-up for the image. Okay, now and then this first daisy, this over here, and this result. Okay, now we go to the our test image, which is like lake with object, which is like, and then we go to the test image once. So we do a Clahi first. I take a shortest one, and then this is contrast the value, and then we go to HC button, which is the output, and then for the hazing, take a longest time, which is like, as you can see, the time. Now it takes 8 seconds to compute the image, and between the first dehazing that signifier, which is only take 1 second. And then now we go to the our proposed technique and effective. So the proposed method one, which is HEDCP. That signifier take a longest time to compute the image, which is take 9 seconds. And then we go to the proposed method 2, which is your HE and fast density induction per year. And then this is our output for this of the test image one. And then now we go to the which is combination between Clahi and DCP, which is proposed method 3. Okay, this one the result for Clahi combination and with that signal per year. This is take the longest time, which is 10 second. By any contrast and luminance shows by any sharpness shows a good value. And then now we go to the our effective image, which is Clahi with fast density induction per year. Now it takes only 2 seconds to compute the image, better than the previous method, which is Clahi DCP. And then we show the contrast and luminance higher than uh, the previous method. Okay, that's all for me. Terima kasih.